forward. Here we go. Okay, moving right along. You need to be able to analyze the data, and you are going to have the data set provided for you, and I'm going to ask you to ask a question of the data and figure out which analysis to actually do to answer that question. So that's kind of the type of research we're going to do in this course. If you choose to go to graduate school, you need to know statistics. Now, oftentimes I get students who are like, oh, I don't want to take a semester of statistics. I'm like, gang, this is, how long are these classes? Like 16 weeks, 14 weeks now, maybe 12. I had to take 2.5 years in graduate school, like full year, not just semester. So lots more stats. And again, don't be scared. I chose to take statistics because let's not dive down that rabbit hole. You probably won't need to take that much, but at least a full year of statistics in graduate school. And then beyond academia, once you get into the workforce, you use statistics all the time, right? In what way have you guys found yourselves or heard of someone else in a day-to-day life interaction actually using statistics? Can you think of examples?
I mean, more mathematically calculating inventory.
Okay, so inventory is kind of observational, right? So you're looking at how much is on the shelf, adding that up, maybe asking yourself what percentage of this product sold last year compared to last year, so you're making comparison, sure. What are some other real world examples from others?
Debates about COVID deaths.
Oh, Ashley, let's go right for it. No, don't unmute yourself. You can't drop a bomb and bow out. Okay, so what do you mean by that?
Just there was like something that was just released by the CDC that said like 96% of the people that got it didn't have comorbidity. So a bunch of people are just saying that all of the deaths don't mean anything now because they had another underlying cause, but that could mean like 9,000 of the people that died had asthma, and like asthma is not what killed them. It was ultimately COVID. So I don't know.
Okay, so this is huge, right? We get something currently in our world, a pandemic, and we are as, I don't know, I was gonna say consumers, Americans, but as people, we are bombarded with data, right? Where are we hearing data from in regards to COVID specifically? Who's giving us data about it?
Too many people.
A lot, yeah, so let's list on those people.
The CDC.
Okay, so CDC.
Fox News. CNN.
Yeah, anybody can type up here. Okay, so you said CNN, is that right?
Yeah.
I'm gonna make that broader into just like news.
Okay.
Right, news media.
Random Facebook friend.
I heard a few, so go back again, what was that?
Random Facebook friend.
Okay, so other general populace, right? Joe Schmo.
Social media.
Social media, okay, what else?
The president.
Okay, politicians, right? Okay, so now, so here's the problem with something like that, right? At the root of it, numbers are numbers, right? If I go like this, okay, maybe you'll, if I say, what is this?
3.
3. Is there much interpretation as to what this is?
No.
No, it's a 3, right? It's a 3. That is an observation of a number. So that it would be the example of Kyle doing inventory, right? The number is the number. One can argue, well, the number could be wrong if you're adding up incorrectly, or if you're like doing inventory at 3 in the morning and you're tired, you might count wrong, right? So if we look at numbers and counts, is there debate as to the number and counts of COVID case?
Yes.
Yes. Why is that?
Because there can be false positives and false negatives, but there's also controversy around hospitals misreporting how people die because they get more money for reporting COVID cases and death.
We are just diving right here, and I am trying to sidestep a lot of issues, but you are, and is this still Ashley speaking up?
Yeah.
Lady friend, more power to you. Okay. So I see 3 areas that are problematic. When we are looking at numbers, let me so how do I want to write this one? It's like a, no, what is it called? I'm about to show you my board here in a second. Not that it's going to blow your mind. I'm just rewriting everything that Ashley wrote. And so that'll be, okay. Can you guys see my board? Let's see. Let me
Yes.
move over to me. So let's see. Oh yeah, no, not really. Okay, so Ashley mentioned 3 things about numbers that are making us question things. So the idea that the way we measure the thing could actually be false. There could be false positive, false negatives, which alters the validity of our number, right? Okay, so this is what I would call measurement error, right? There's no human introduction here. It is just measurement error because of the tools that are obtainable or valid for us, right? Second, misrepresentation, right? So this would be, oh, we've got another COVID case right here. But in fact, well, did they die of that or did they die of something else? We've got a little gray, right? So that would be a misrepresentation. And in that category, we could say human manipulation or human bias may be part of it, right? That may play a role into the differences of numbers. And then the last one, we've got observer bias or observer change. So in, and I was so excited, I threw my cap, there it is. I was like, shook, threw it over. When we do some form of qualitative research, and even in quantitative research, actually, if you have 2 researchers that are observing the same thing, they may differ in their rates as they're counting, right, in their observation. So there is, you want to have good observer reliability is what it's called, so that the numbers come together quite well. So that means you are observing a similar event and coming to the same conclusion. In the case of COVID, it would be, here's the data, right, that says that this person is positive, and 2 people agree on it. And when there's the disparity, that's when there's a problem, right? And so this is what we're observing at large, or what we're being told is there's variability within that. Okay, so this was really good. This is a real life world problem where statistics are very much at play. And being able to have our own understanding of politics allows for the sources that we listed, right? We listed CDC medical research, right? We listed Joe Schmo, friend, person who has an opinion, because why not? We all have opinions. News media, we talked earlier about bias, right? Maybe there's a bias, maybe there's a reason why they're presenting the information in a certain way. Politicians, I would say there's probably a bias there too, right? There's a reason why they want the information one way or the other. Social media. So, right, the way we are absorbing and acting as sponges for all of this data has an impact, has a huge impact on how we then interpret the numbers. So if we ourselves are not feeling strong as to our understanding of statistics and can ask questions, Ashley, you started with the example that said 96% of folks, I think that what you meant to say is that they passed away because they had an underlying condition. Is that correct?
They were saying that like the majority of people that died of COVID had some sort of underlying condition, but it doesn't mean that it was
right,
like something super severe that they couldn't have lived like 30 plus more years with. So
right. In fact, I think the graph I saw, and please correct me if you're thinking of something else, because again, different sources, right? The one I saw was a pie chart, right? Ooh, pie chart. Get excited about that. That divided that 96% into like 55% were just old, right? So they qualified as like 65 and over, 75 and older. And the other 41, whatever was left over of that 96 had a pre-existing condition. But again, how do we qualify that? So again, you're given data, and if you don't know how to read it and you have no understanding, maybe you're like, oh, well, let's pretend that I'm 29. I'm just gonna go with that. I'm 29 and fairly healthy lady, so no big thing, right? So, but until we actually dissect what it actually means, right, and have an understanding of it, then that's when we get the good understanding. Yeah. And I want to sidestep away from COVID for a hot minute, if that's cool. Okay, other examples that are maybe less controversial. What do we think? Other examples of stats? You guys are all college students. You often take exams. Are there ever stats with that?
Well, sorry, not an exam, but would the sports statistics be a...
Totally.
Okay, awesome.
Thank you. Yeah, okay, so what would be a sports that actually probably does the most statistics?
Baseball.
Baseball, right? Okay, so little tidbit about Dr. Wolto. When I was in 6th grade, I would stay up late at night with like a notebook very similar to this, right? A little legal pad, and have the radio on and listen to the games. Now, did I like baseball? I did not, but I had the entire roster and I would say whether they hit, whether they missed, right? And I would calculate my own stats. This is the state of nerdiness that I'm talking about here, people. That is, so baseball is all about stats. RBI, right? All of the percentage, how often they hit, it's all statistics. So that's a fantastic example. And if we don't have a good understanding of statistics, we might think that a pitcher, right? And that's in the national leagues that pitchers are allowed to hit. Is that right? No, see, I don't know anything about baseball really, but if he hit the ball once and has only been at bat twice, he may seem like he has the greatest hit record compared to someone else who is at bat all the time and is actually fairly good, but because they have more opportunities at bat, right, that percentage is going to seem a little lower. So without your understanding of statistics and maybe your understanding of baseball at large, you might end up making a bad prediction as to who is more likely to hit, a seasoned hitter versus a pitcher. Do we have athletes in this room? Did I just totally embarrass myself? Does that make sense, what I just described?
I thought it made pretty good sense.
Okay, thank you, but you seem very forgiving, Kyle. Yeah. Okay, all right, lots of examples. The good example I like to bring up is, not that I lived in California for a long time, so we went to Vegas occasionally. When you're in Vegas, do we do stats?
All the time. Gambling.
All the time, right? As people are standing next to the roulette table, deciding where their $50 is gonna land, they are making a choice based on their understanding of statistics. Now, what would you say is someone's understanding of statistics next to a roulette table? What are your thoughts?
Poor.
Poor. Okay, why is that?
Because there's so many different, because I don't really know what a roulette or how many options are in a roulette table, but it seems that the odds are so stacked against them because it's picking a number while also trying to calculate how fast the ball is going around just to land in that number.
Yep.
So,
Okay.
that's
Other
stick to
thoughts?
black.
Yeah. Okay.
I think people at a roulette table have a generally good understanding because you can like figure out the probability of you picking a specific number or just picking a color, or
Okay.
like there's different options and you have a better chance of winning if you just pick a color rather than trying to get a specific number.
Always bet on black.
Ashley, I love that. I want to edit that sentence. You have a better chance of winning if you pick a color than if you pick a number. I would say you have a greater probability of getting your money, right? If you pick a color, because what are the choices of color?
Red and black.
Red and black, except
For
Just green.
one white
there's also green, right?
or green.
And you're like, what I'm talking about, so it's got a board that looks like this. Ooh, that's not good, but okay.
Aren't the zeros green or something?
Right.
Okay.
And some boards only have a single zero, others have a double zero. So if you go to a single zero, right, okay, so it's kind of like this, right? There's a bunch of numbers here, and then off to the side, you can say, I bet totally on black or I bet on red. But the odds here are not an exact 50% because there's also the green zero, right? But there's 1 0 or a 0 and a double zero on a wheel that I think has 36 numbers. I could be wrong about that, but something like that. Now, in Vegas, what I love to see is you get these people who are like, they are into it, right? And they have their notepads and they are ready to tell you what is most likely to hit. And they talk about it saying, because oftentimes there's a board, it's an electronic board, that'll list, it'll go something like this. I'm writing it down, just give me 2 seconds here. And I'm making up these numbers, this is probably inaccurate, but it'll be a board like that, right? And one side is red and the other side is black, and it'll list the number that was last called. and they sit there and they're like, well, look at this. Black is due to come because look how many reds there were just in a row. What do we think about that?
I think that's how people keep staying at, because they think, well, I'm due for a red when there's nothing that will ever make a red more due just because it hasn't been called.
100%. So in roulette, so I'm going to use some stats terms here. In roulette, each spin is an independent event, meaning the last event and the next event, there's no connection at all, right? They're completely unrelated. So whether it is gone that many times red, yeah, you still have the same odds. As soon as that ball is dropped, you have the same odds for red and black and green every single time. Does not matter history. It's not like human behavior, right? And this is why we superimpose this idea onto roulette. In human behavior, there's an old saying that says the best predictor of future behavior is past behavior, right? If I know myself that I am a procrastinator and I wait until the last minute to do everything, and then I somehow expect that this semester is going to be completely different and I'm going to be on top of all my reading, on top of all my assignments, all my projects, but I have not set up a system in which to make that happen, the best predictor of how I will perform this semester is past behavior, which is I will likely engage in exactly the same thing. In the world of statistics, especially with independent events, that is not the case. So, all to say, this is a real life example, right? Where you have to know some statistics to be able to look at those folks and go, walk away, stop spending your money, right? So, okay. Any other examples that come to mind? Otherwise, I think we kind of have the right idea. What are your thoughts? Good? Okay. Let's keep on going. So, the research process, what does that look like? It is a set of activities that as social scientists, we engage in. So there's a repeated process we go through to answer specific research questions. And that is how it needs to start. It needs to start at first with a question, or maybe you have some idea, or you have a theory that you've heard of and that you'd like to actually test out. So it starts there at the research question, and that'll then lead on to a whole process for you to gather data to support or refute your original idea, hypothesis, or theory. The data that you gather, it's specific numbers that you will then be able to analyze using statistics, either through descriptive methods or inferential statistics. That's kind of where it breaks off again. And what is statistics just as a whole? It's a set of procedures to organize, summarize, and also communicate numerical information. And I cannot underscore that enough. In this course, not only are we organizing data, and we can do that in a frequency table, for instance, when you have a long list of data and you organize it so it's in certain categories, right? And then being able to summarize, so do some sort of analysis, like a mean, for instance. If you do a mean, you're summarizing what the data means. And then how to communicate it. And that's the part of social sciences that's quite different than other domains, because usually math, you guys have probably been in math classes before, where you just circle a number at the end of your process and you're like, this is the answer, right? If I'm trying to figure out what is 20 divided by 5, the answer is 4. There doesn't need to be a long explanation unless you're in elementary school and engaging in Common Core, but usually it's like, this is that because that's how it is. That is the reason, that's how math works. In statistics, you need to actually communicate what it means. And we will work on that this semester on how to describe the result, right? Because it's not just saying these two groups showed a t-test that was 1.96, which was statistically significant. We need to take it a step further, which means the two groups are in fact different from one another, and it is not due to chance. It's because of inherently they're statistically different than one another, something like that. We'll work on that language. Okay. So again, the theory, there's kind of double arrows here, right? Because the theory impacts or influences which question you ask, which then influences how you formulate a hypothesis, which leads to how you'll collect data, how you'll analyze data, and eventually how you'll evaluate that original hypothesis. And once you get here, you're not done, right? whenever somebody asks, or if you're reading a paper and it talks about future research, that's what it's about, right? It's like I had this question, I designed how I was going to find out my question. This is what I think is going to happen. I got data. Wow, this is what happened. Now I'm wondering about, and the circle just starts all over. And at all points of the circle, we feed back into theory, because the theory is something that is moving, right? It's not something that is crystallized. It's ever evolving. Every time we have new data, it impacts our theory. So that's the research process. So how do we go about asking a research question, and what does that look like? So empirical research, what is that? It is research that's based on information that can be verified by using direct experience. So if you think back to like philosophy courses, the empiricists, they wanted to see it, right? See it to believe it. That's exactly the same. So an empirical research means I can engage in the research process and be able to replicate whatever you did, Mr. and Mrs. Researcher, 10 years ago, because I can go through the research process myself. It is not only relied upon reasoning, speculation, moral judgment, or even a subjective preference. It is something that can be measured again. So you're trying to reduce the amount of bias and the amount of researcher inserted variability, because it can be empirically observed and measured. So for instance, an empirical question would be, are women paid less than men for the same type of work? Okay, why is that an empirical question?
Because you can check, or you can compare women's salaries to men's salaries, and then you can do that on a very large scale.
Exactly. So I can say that I have a feeling about it, but that's not what we're talking about here. We are talking about an actual measurement. So I can go and poll university professors, for instance, and ask the human resource department to give me the average salary for men, average salary for women at the same level in academia. And then I compare those values. And then my question is, are they in fact significantly different, meaning not different by like $1? They're significantly different based on the sample size, and is it in the way that I suspect, right? Because this is not saying that women are paid a different amount than men. There's actually like a direction. They're paid less than men. So I want to see if that's actually true. So that would be an example of an empirical question that you can ask.
Sorry to interrupt, is it still empirical if we ask that question, like, are women paid less than men in like 1960 versus 2020? Like,
Yes.
okay.
That is still an empirical question, because it is still a number that you can observe and look at, and it's not based on an opinion, because there's probably data. Now, that would be a harder question to actually fill out, because you need to account for inflation and the differences in salary between those times. But what you could do is take a look at men and women in 1960s, men and women in now, right? And see if the difference existed then. And does that make sense?
Yeah.
You would need to have a data source that had that information. You can't go back in the past and guess, right? That would not be empirical. Yeah. So a question that would not be empirical is racial equality good for society? Right? It's a valid question, right? It's one that's worth philosophizing over, but it's not something that we can really measure effectively, and it is based on values. Whenever you say good or bad, you need to quantify that somewhere, right? Like otherwise, I don't know what that looks like. Yeah.
Sorry to interrupt,
Yeah.
but your audio's coming in a little like vibraty,
Ooh.
and I think that's for everyone.
Yeah,
I
I'm
could
not
be
sure
wrong.
why.
Yeah.
Okay. Like still?
Yeah, it's
Yeah.
like if
It
you're
was
trying to
fine at the
like, move your
beginning.
throat up and down, and it's like. Ugh.
Okay. I'm definitely not doing that, and I'm seeing there's a chat here. Oh, yeah, Eliza was trying to tell me. Okay, is it still like that right now?
Yeah.
Okay. I'm gonna take an early break, and I'm gonna go get my microphone. Let me shut it all down for 2 seconds. Maybe it's a connection.
Maybe.
Okay.
We can still hear what you're saying. It's
Just
Yeah.
sounds weird.
yeah.
Like there's an overlay back. It's like we can hear your voice, and then it's.
So I guess it's It doesn't like, yeah, we can still hear what you're saying, so I guess it doesn't need, we could try restarting it, but at the end of the day, it doesn't really matter.
Okay. This is a good time. It's 2:45. I'd said 3 o'clock, just a little ahead of schedule. Why don't we all lock back in by 3? I'm going to shut this down. I'm going to get my headset to just try to minimize as many options as possible. Let's come right back. Sounds good?
Awesome.
Yep.
Thanks so much.
Okay. Thanks for letting me know, guys.